Chapter 2. Capacitance and Capacitors. 2.15. Kirchhoff's Laws. Kirchhoff's laws are very useful in analyzing multi-loop circuits. He provided two laws. These are junction rule. The algebraic sum of the charges or currents at any junction is Z for charge. At junction A, as shown in Fig. 2.66, 9 plus 92. For current, at A, itinti, I plus is. Loop rule. The algebraic sum of the potentia differences across all the circuit elements in a closed loop, including with EMIS, must equal to 0. REV equals sign N circuit having resistors and cells. Then 25 plus EIR equals sign 0 circuit having capacitors and cells. Then equals sign 0 C circuit having resistors, capacitors and cells. There is plus 27 plus EIR. The iuction rule is an application of the principle of conservation of charge. The Lune rule is a consequence of conservation of Enerov. For circuit analysis, the following procedures should be followed carefully. First of all, label all the known and unknown carefully, including an assumed sense of direction for each unknown. Often one does not know in advance the actual direction or sign of an unknown current, EMT or charge. But this does not matter. The solution is carried out using the assumed directions, and if the actual direction of a particular quantity is opposite to the assumed direction, the value of the following guidelines and sign conventions are useful in Analvicino circuit problems. One must remember that the current in ANV resistor or charge on an capacitor 15, the net response of all the sources present in the circuit. Don't think that on nearest one is sending the current or charge. Choose any closed Lune in the network and designate a direction, clockwise or anti-clockwise, to traverse the Lune for Lune rule. Close loop MAV or MAV not have ANV cell, but one of the close Lune must include the cell. For a circuit having only one cell, choose a close loop, which include this. A. The PD across any resistor can be taken negative when moves along the direction of current and positive for reverse direction of current. B. The PD across capacitor can be taken negative when moves from positive plate of capacitor to negative plate and positive for reverse sense. Note: see the sign of charge of first coming plate of capacitor only. C. The EMF of any cell battery is taken as negative from its positive terminal. Electricity and magnetism. Fig. 2.69, 2.71. It must be remembered that capacitor in steady state stop the direct current, and so there will be no current in the branch in which capacitor is connected. If capacitors are connected in series with the sources as shown, the charge on each capacitor will be same. It must be remembered that the net charge Sun VBR cell will be 0. Finally, the number of equations obtained must always be equal to the number of Lil kilo WS. The RC series circuit, A, charging. Consider the circuit as shown in Fig. 2.73. If the capacitor initially has no charge, then the initial PD across the capacitor is 0, and the entire EMT appears across parator, causing an initial orant I equals sign 5. As the capacitor charges, its potentia increases, and PD across resistor decreases, corresponding to a decrease in current alter a long time when capacitor becomes lully charged. The entire potential will occur across capacitor and the current becomes 0. Let at any instant the current in the resistor 1S1. Then by loop result, IR 09R9 plus Euro asterisk R equals sign 5, Un 68. Integrating above expression, we navet 2.72 or 10, 6 yong ins, deung or mun. I substituting C $ equals sign go, the maximum or steady state charge on the capacitor and ret. Canacitive time constant N1, 99 equals sign 901, E1T. Trent. 9 equal sign 9 xe1 equal sign 15 LRC, and at t equal sign 00. It means initially capacitor offers no resistance in the circuit, but alter charging Tully, it allers inlinite resistance. Potential oil capacitor, potential equal sign 99011 equal sign vol elt. Energy stored, capacitive time constant, T, equal sign 90, 1, E1, 0, 6490.37 Ig. Therefore, time constant is the time in which charge on the capacitor grows to 0.64 times the maximum charge, or current decreases to 0.37 times the maximum current. Discharging. After charging the capacitor, let now source is removed from the circuit. The energy stored in capacitor now used to flow the current. At T equal sign, we have GE, Cana, again by loop rule Fig, 2.73 Fig, 2.74 electricity and magnetism, IR, I equal sign N, where G is the charge on capacitor at any time to minus 44 R equal sign, day equal sign, RC integrating above expression, we get day current. In 490 Y equal sign Quetalt I, me F we us, we TR, equal sign day unge, Erie sis, as RC equal sign to energy Fig. 2.7. Finding the time constant F, there are MAN-V resistors and capacitors are connected in the circuit. Then time constant can be obtained by using Jollowing steps. Make short circuit at the place of battery. Find equivalent capacitance, if there are many capacitors in the circuit. Assuming in, find net resistance across the capacitor, say it is R IV, Reinally. T plus equal sign, R net, C net capacitance.